In this tutorial, we'll show you how you can make your birthday book class iterable. So to start with, go to the lecture site and then download the starter code for the birthday book, which you have been practicing. And download the archive file, and then, assuming that you save it on the desktop, for example, and then unzip it, and then open with iPhone Studio and compile that. Okay, everything should compile to begin with. And let me just go to my iPhone Studio, and it is already compiled. So what we want to do is, if you go to under model cluster and go to the birthday book class over here, you can see currently we simply just inherit from any and redefine the out like a toString method for the output. Now what we want to do is to add another parent class for this birthday book, which will be iterable. And let's think about, would this be the easy case or the hard case for you to implement? It seems to be an easy case because if you look at the current implementation, it's simply a hash table where the key is the name and the value is the birthday. Okay, and it seems like maybe we can simply implement the iterator pattern by using imp.newCursor, like an easy case. However, it may not turn out to be that easy. So let's do a little bit analysis over here. But from the client side, okay, later on we're going to write some test cases, but let's do it quickly for now. So if I go to the tests over here, let me just create a new test for you. Okay, I will say add Boolean case, and then I'm going to create, let's say T2. I'm going to define that right away. And then it's just going to be a new test case. Let's write it down here. Okay, and later on we're gonna, as soon as we finish our implementation for the supplier side, we can run the test. So T2 also a Boolean test case. And then it has one local variable, let's say just the birthday book, BB, okay, birthday book. And then do over here, and then give some comments over here, let's say T2, and then you would say test of iterable birthday book. Okay, let's see how we are expecting the clients to actually use our iterable birthday book, which we're going to implement in just a moment. Apparently, if BB, the birthday book, was iterable, then we can simply use across BB directly. So we'll say across, and then we'll say BB. Okay, and now if I simply say is the syntax over here, let's say is, I would like to retrieve entry by entry in the birthday book, and each entry should be, let's say, a tuple, and the tuple should contain maybe the birthday followed by the name. Let's say that's how I want to set it up. So now I simply say entry over here, and then over here maybe I'll simply just do a loop over here, and then end. Okay, it's just a cross loop. So now is this going to compile? If you try it, if you say compile over here, of course it says that it's not going to compile because since you're using a cross keyword, so what it is expecting is something that should be iterable. However, it's only a birthday book, and now birthday book, we should really make it a descendant class of iterable. That's what this compilation error message is about. So what we should do now is to go back to our birthday book class over here, and then we want to make iterable as one of the ancestor classes. Okay, let's try that very quickly, and let's see why simply choosing the easy case to implement would not be the way to go. Okay, well, the inherits also iterable. Okay, and then we can say iterable something over here. I'll put question mark just for now. Okay, and then just for this particular case, since we already redefined the out feature, so you have to also say redefine out. Okay, just something you want to pay attention to. Otherwise, you get some clash. Okay, also say redefine out. Okay, this is nothing to do with the iterator pattern. So what should we put for the question mark over here? So as I said in the class, whatever type you put over here should be the type in the corresponding clients. So now if I go to the client side, if I go to the tests over here, if I go to the tests and I go to T2, what do I expect this entry to be? What should be its type? So now maybe what I expect to happen is, let's say expected each entry retrieved from the iterable birthday book is a tuple, and then it should be, let's say, birthday followed by the name. Let's say this is how I want the setup to be. Once we complete this tutorial, you can try maybe a different order as an exercise. You can do it later. So now this is what we expect it to be from the client side. So now we should really implement accordingly in the supplier. So now in the supplier, I'm just going to put tuple of, let's say, birthday and then also name. Okay. So now as soon as we hit compile, of course, it's going to complain because it says that the class birthday book has deferred feature, and this deferred feature is exactly the one that we inherited from iterable. Remember, in the iterable, there's a deferred feature new cursor. So now we have to implement it, right? So now if I just put it in the beginning, okay, so I will simply say feature over here. Let's say that's the iterable feature. The only thing we need to implement is new cursor. New cursor. And that should be an iteration cursor. Okay, and then this type over here should be consistent with what we expect the each entry to be retrieved by the client to be, right? So now what I will do is I'm just going to copy this particular guy here, right? That's what we said before. Whatever you decide for the iterable generic parameter, it should be consistent for the new cursor, for the iteration cursor generic parameter as well. Okay, they should be consistent. Again, we're expecting each client of this particular iterable birthday book, they will retrieve one tuple at a time. Okay, so that's why they should be consistent. And now, what should we do over here? Okay, do result. Now, you might think, because there's only a single data structure imp of type hash table, and let me just remind you, let me just something I want you to look at. Go in iPhone Studio. You can see hash table over here turned out to be iterable. Okay, let me just tell you, show you how you can find it. First of all, hash table takes two generic parameter. This will be the value, and this will be the search key, which has to be hashable. It's constrained genericity. And you don't really see iterable directly over here. It's kind of indirect. So I will show you how you can find that path. First of all, you can see hash table inherits from readable indexable. Okay, if you go there, readable indexable actually inherits from iterable, so it's kind of indirect. And I will show you a little bit more just in a moment. Okay, but let's now go back to hash table over here. There's one more thing I want you to look at, and later on we're going to revisit a little bit later for the reasoning. If you go to hash table, first of all, we agree hash table is actually one of the iterable descendant classes, so you can definitely get a new cursor. So now if I type new cursor over here, you can see for the hash table, they have their own iteration cursor class called hash table iteration cursor. Itself takes two generic parameter, the value and also the key. Okay, that's something I want you to make a note. And then when we actually return a new cursor from the hash table, you simply create this particular hash table iteration cursor instance. Okay, one more thing I want you to look at. Let's go to this class specifically. Okay, let me simply pick it. Okay, I want to have a new tab. Let me type it out. So hash table iteration cursor. If I go there, you can see for this particular hash table iteration cursor, you can also try to go deeper to see. Eventually, you can see one of the ancestor is the iteration cursor. I'll leave that to you. Okay. Before that, I want you to look at all the features that are supported by hash table iteration cursor, because hash table iteration cursor is a descendant class of iteration cursor. It must support at least 3 features: the item, the fourth, and after. So now let me show you the features panel. Okay, so now I'm still in the hash table iteration cursor. We'll deal with this particular compilation error in birthday book in just a moment. Let's clarify stuff first. Hash table iteration cursor, and then you can see over there, you will see things like hash table iteration cursor. Can I actually see hash table? Okay, so now make sure you hit enter on the class field so you can see the features accordingly here. For the hash table iteration cursor class, what features do we have? We got fourth, we got after, we also got item. And notice that we also got something extra, because in the descending classes, you can feel free to introduce new features as in the inheritance. Okay? So these are the classes I want you to at least to study carefully for this particular tutorial in order to fully understand it. So now here's my question for you. Given that the hash table, which is the implementation type, is a base class that's iterable. Would this simply work just like the easy case if I simply say the following? Result is assigned to imp, which is hash table dot new cursor. That's the question. Would this particular one-line implementation satisfy this particular error? Would it actually resolve this particular error? Let's try. If I say compile, actually it's really not working. Okay, and then the error message, you can try to read it a little bit further. I'll leave it to you, but it has to do with somehow the type for iterable. You can see for our particular case for the birthday book, the iterable should be a tuple of birthday and name, and the compiler is now complaining if you simply use new cursor as a return value, it's not really conforming to what you instantiated G to be in the iterable. Okay, that's basically what the error message is saying. But I would like to illustrate this further. Okay, so now I'm going to go back and forth between the iPhone Studio and the iPad to show you how to understand this particular error and see why it turns out to really make birthday book iterable, it turned out to be the hard case, not the easy case. Let me switch to iPad over here. So that's really the classes I've already been talking about. Let's see that very quickly. Okay. So now I want you to let me go one by one. For the iterator pattern, we have the iterable class over here, and also we have the iteration cursor class over here. And of course, the new cursor is something you must implement if you want to instantiate a pattern. And of course, new cursor is deferred. For our particular class, which is birthday book, as soon as we make it iterable, we have to somehow support new cursor feature, right? But now, how do we implement the new cursor feature? Let's see why. What I just illustrated in iPhone Studio was, if I simply say the birthday book is simply just going to return its particular new cursor over here as a hash table iteration cursor, it's not going to work because you got a compilation error as I just showed you. Right? So now let me make it clear here. So if I simply say new cursor over here, conceptually, so that should be implemented, right? Because that's implemented from the hash table class. But this is not going to work. It's not going to compile. But let's now explain why this will not compile. Okay? So here's how you can think of it. In your birthday book, let me remind you, let me go step by step. In your birthday book, you can see you declare the implementation to be a hash table from birthday into name. Okay, so now you can see by following this particular, let me just draw more clearly. By following this particular client-supply relation, you have a hash table. You instantiate the G to be birthday, also BD, and also instantiate K to be the name for that particular case, right? So you got birthday, also you got name. So now, in order to really return the new cursor from hash table, as we said before, if you look at hash table, you go to new cursor, it's going to return a hash table iteration cursor with G and K. Okay, so now that means hash table iteration cursor is exactly over here. So now the new cursor returned by hash table is going to be a particular instance of hash table iteration cursor, and now G would be birthday, right? This corresponds to this, and also the K should be name, and this particular name of course corresponds to the name over here. Okay, hopefully so far so good. So now why it will not work in this particular case? Again, if you go back to hash table iteration cursor, you can see the item feature as I showed you previously. Item, rather than returning a tuple of G and H, G and K, it actually just returned G. So what that means is, you can see this particular G here is really the G here. So that means you only return just the birthday. So that means as far as the new cursor for hash table that's already defined is concerned, they only return one birthday at a time, which is inconsistent with what we really want to achieve. So what do we want to achieve? Remember in the birthday book over here, you can see the birthday book actually inherits from iterable of tuple birthday and name. Let me put it down. Okay, so now you can see for this particular instantiation for the birthday book, let me use orange here. For our birthday book, it inherits from iterable of tuple of birthday and also name. So what we are really expecting is a tuple from the birthday book's point of view. However, if we simply use the new cursor that's from the hash table, it turns out we will only get one birthday at a time, as opposed to one tuple at a time. Hopefully you see that issue here. Okay, so as opposed to one tuple at a time, we only get one birthday at a time. So we got inconsistency over here, right? One more thing to say. Okay, so now you can see over here in hash table iteration cursor, as you will see, that one there simply inherits from some iteration cursor. Let me just go a little bit deeper for you. Okay, it inherits from readable indexable iteration cursor. If you simply go to that particular class, you can see that one there. Okay, you're gonna go further, type indexable iteration cursor, choose it, and then go there. Okay, we're going further up to the ancestor path, and also indexable iteration cursor, go one more level. Okay, so eventually we see that it will actually inherit from iteration cursor over here. So what I really want to show you is this part here, iteration cursor, has only one G. Okay, you can see iteration cursor is exactly over here, but when we look at the hash table iteration cursor, let me go back there for you. So hash table iteration cursor actually has G and K, so we're missing the K. It's just a design choice made by IFO-based library. Okay, let me make it clear here. You can see over here for hash table iteration cursor, that one there has BD and name as the generic parameter. But now, when it actually inherits from over here, the iteration cursor, it only puts the G, which is BD. Okay, that's why the item should only be just BD. It's just a design choice. So overall, we have an inconsistency. So here, what the hash table iteration cursor will return one at a time is simply just a birthday, which is inconsistent with what we really want, which is a tuple of birthday and name. Okay, hopefully you get this issue straight to realize it is not an easy case that you originally thought. So we should do the harder case, which means we have to really create a new class, descending class of iteration cursor, and do the stuff from there. Okay, that's what we're going to do. Let me sketch out what we're going to do at the iPad, and then we'll do it together in the iPhone Studio. Okay, so now, but before you move on, make sure you really understand from the design point of view why simply returning new cursor from the hash table is the wrong way to go, because the expectation is simply not being met. Okay, let's now go for the same diagram. So now we're going to see how we can do it. Okay, so what I would like to do is like this. I want to go for the hard case, which means I'm going to create a new class, new subclass of iteration cursor. Let's say I call that my hash table iteration cursor. So I'll put it here. I'm going to say inherits from over here my hash table iteration cursor. That's kind of the idea. And then let's have this particular class take maybe G and also H. Okay, both the value and also the key. Okay, you can think about eventually this will be BD eventually, and this will just be the name eventually. Okay, for our particular example, let's say I create this particular iteration cursor class, and then I'm going to define my own new cursor objects. Okay, and when I actually inherit from this, so now for the iteration cursor here, rather than right in the previous case, you simply just got a G, just a BD. So now I want to make this guy here tuple of maybe the G and also H. Right? That's what I want to achieve. Okay? So accordingly, this return value over here would just be tuple of G and H. So now we are aiming for a different design. Right? So now once I got this, I can now implement a new cursor accordingly. And the way to do it is simply just have a client-supply relation. So that means my birthday book is now going to use this particular my hash table iteration cursor. So this will now be my new implementation, new cursor. Okay, hopefully you can see the difference between the two design. In this case, in the correct design, we're going to have the new cursor pointing to a new class that we created. Rather than in the previous case, we simply say just implement the new cursor being something that's already available to us. If whatever that's available to you works, that's good. That will be the easy case. If it doesn't work, you have to go for the hard case. let's now see how we can implement this particular implementation. Let me do the coding now, and then I will explain a little bit further to see how that works at the runtime. Okay, that's one step at a time. What I will do now is go back to birthday book, and then I want to create a new cursor class. Okay, so now rather than having implementation a new cursor, okay, let me make a note for you. Does not work for the reason I just explained on the iPad. So now what I would like to do is to create a new class. Let me go under model cluster, and then I'll create a new class. Let's say my hash table iteration cursor. So what should really know the difference between this my hash table iteration cursor versus the hash table iteration cursor in the base library. In the hash table iteration cursor, it only returns one birthday, or like a one value at a time. Whereas for our particular customized iteration cursor class, we want to return one tuple at a time. Okay, that's a critical difference. If I say creates, and now I need to accept generic parameter. In our case, we want to make sure we actually have both the G and also the K, right? Because we got hash table. So now if you go back to our birthday book class over there, let me just find it. And if I go to, okay, maybe I missed it. Okay, so let me just clean the all the tabs, so that'll be easier. Okay, that's my new cursor class. If I go back to birthday book. Okay, if you look at the implementation here, it should be over here, it should be birthday and name, right? So that would be like something that's G and this is H. And notice that because the name is is actually as the key, search key for hash table. If you look at the hash table over here, you can see this particular K must be hashable. Okay, that's something you want to be careful about. So what I would do is, if I go to the class over here, now I'm going to put the G over here and also H. So that should be hashable. Okay, so now we're going to define this particular my hash table iteration cursor class. First of all, it should inherit from iteration cursor. Okay, that's something I should do first. And then I should say inherits. Okay, inherits iteration cursor. And whatever I put over here should be basically what I expect to return back to the clients one at a time. So that should be a tuple. So now I would say tuple over here. And then I'll put G and I'll put H. Okay, so far so good. And then I should create have some constructor over here by listing the create class. Create, and then I'll say make. First of all, I will have some commands for me to initialize the iteration cursor. Now, in order to initiate the initial iteration cursor, I should just take maybe just the implementation itself. Okay, so I can return something from there later. So now I will simply go back to this iteration cursor class, and then I would say make. Okay, let's say hash table. Hash table. Or you can say imp. I think imp is fine. Okay, hash table. Okay, let me just make it for. Okay, hash table, and then that should be over here. G and H. You can see now, since we are passing H, which is hashable, so this one will make compiler happy. Okay, so now let's also define the implementation for the iteration cursor, and that should be hidden for information hiding. Okay, so that will be implementation, and the implementation will just be the same as the birthday book, since we want to iterate through the birthday book. So that would be simply hash table, and then I'll simply put G and H over here. So now it will be as easy as, oh, let me just make a different name. How about hash table, HT? I would say the hash table internally will just be just the imp over here. Okay, we are just going to make sure we also implement all the defer feature from the iteration cursor. For example, we're gonna implement item. We have to implement after, and also we have to implement the fourth. We're gonna implement all of them. Okay, let's do that quickly. And now I'm going to have another feature section. Notice that every time you have a new feature section, you simply got a new section over here in the features panel. Just notice that. Okay, it's actually for good exploration of your projects. So now feature over here, let's say cursor operation. So we're going to do item, and now the type for the item should be consistent with whatever generic type it is over here. Right? So you should be here and then do an end. Again, we're going to assign that the result to be some value. We'll do that in just a moment. And also after, which would be a Boolean. And also we got fourth. Okay, that's a command, so just like that. Okay. Of course, the compiler is going to complain that your result is actually not initialized, but we'll deal with that in just a moment. Okay, I'll do that a little bit later. Okay, so now let's see over here. What we want to do now is to complete a little bit more coding from the birthday book side. If I go to the birthday book, okay, if I try to compile that, okay, so now what I need to do now is go back to the new cursor over here, and now I want to initialize an objects for iteration cursor, right? Now that I created this particular my hash table iteration cursor, I want to use it as the dynamic type for the result. So what I will do is creates, and now I can set my hash table iteration cursor. Okay, let me make sure I spelled it correctly. The iteration cursor, and then always if you mention some class as generic, you have to give the type of the generic parameters. In this case, it will be G and H, so that should be birthday followed by name. So now I'll go over here, and then I'll simply type birthday and also the name. Okay, and then I can say result, which will be the return value for this particular new cursor feature, and then I'll say result.make. And what should I pass over there? I should pass basically the implementation, which is a hash table, right? So now I will pass the implementation over here, and let's see what else the compiler might not be happy about. Okay, let's see over here. What's really let's see this. Okay, for the entry, we're gonna deal with the client in just a moment. Okay, what I want to now, let me just at the moment, let me simply just comment this out just for now. Okay, let me just make sure everything is fine except for the result over here for item in the iteration cursor class. In the hash table iteration cursor class is not implemented, right? That's the only thing. So now let me talk about a little bit idea about how this iteration cursor class will work before I talk about the implementation. Let me go back to iPad over here, and then let me start a new page, and then let's describe that very quickly. Okay. Think about the following. At the runtime, I have my birthday book, let's say BB. Okay, BB is pointing to a birthday book objects. Okay, birthday book objects. And part of it is something that should be hidden, which is the hash table. Okay, I'm just gonna use maybe a dark color just which means it's private, it should be hidden. So now in this case, it will be just implementation. That one there is simply pointing to a hash table. I'm just gonna visualize that as a two-column table. Okay, and the hash table simply has the key and also the value. Okay, let's say we got three rows at the moment. Let's say we got Alan, we got Mark, and also we got Tom. Let's say I'll make up the birthday. Let's say September 24th, October 10th, and also August 13th, right? Just got different name and birthday entries over here. Okay, that's basically, so this part here is hidden from the clients. Okay, so now in order for me to visualize how the iteration cursor class works, let's see this. So whenever I say BB, let me use a different color. If I say BB dot new cursor, it will basically point to a iteration cursor objects. In this case, it will be hash table iteration, my hash table iteration cursor. So that will be my hash table iteration cursor. Specifically, it will be the birthday and also the name, right? Okay, and then that part over there also has some implementation, which is the hash table. Okay, so now you can think about that part there is also hidden, and that part, the implementation, is basically aliased to the same table internally. Okay, the clients from the clients of either the new cursor or the clients of the birthday book, they cannot see the underlying hash table. So that's the point about the iterator pattern. So now how can we actually implement this particular thing over here? So what we want to do is like this. So we have to implement item, we have to implement the after, and also we want to implement the fourth. So these are the three features we want to implement. Remember I said we actually cannot simply just use the iteration cursor that's actually returned by the hash table, right? But it turns out we can use it, but you gotta be also call some specific features. How do I know? Because I read the API. So now I want to show you how you can do it quickly. If you go back to hash table iteration cursor. Okay, let me just go back to the class over there. Again, okay, easier if I go to hash table over here, and then I will go to new cursor as hash table iteration cursor. Okay, let me just pick that and then go there. Okay, so now if I look at the hash table iteration cursor, what I want to see is over here. Okay, let me just go back to the new cursor. Okay, new cursor. Oh, I'm so sorry. Okay, now hash table iteration cursor is fine, but I want to see what features will be supported. So now what I want to do is look at the hash table iteration cursor and then hit enter. So these are all the features that supported. We got item, we got after, we got fourth, and also the key. So the key here is really crucial in order for us to make things work. Okay, so now I will switch back to iPad and see how we can do it. Basically, so now I'm thinking this way. If I say over here, let me use a different color. If I say bb dot implementation, so I'm basically referring to this particular hash table, and then I say new cursor. So now I'm basically talking about a new cursor that's returned by the hash table iteration cursor, and we know that it supports both the item and the key. So item would be whatever item that's currently being iterated where the cursor position is, and key is whatever the key of the associated item. Okay, let me visualize that for you. If you do this, it's now going to just return another iteration cursor objects. Okay, so now this would be hash table iteration cursor. Okay, that's what you'll get. And then over there, of course, it's going to have key and also item, right? Okay, so these are the two public features that I just illustrated to you. You can see the key here and the item here. So now how can I use this particular cursor in order to suit my need? Think in this case. Every time, if I say, let me just make this a little bit shorter. Can I just say this is X? Okay, just for now. Okay, every time if I say X.key, it's going to give me some key. If I say X.item, it's going to give me some birthday value, right? So you can think about initially when this particular cursor is first initialized, key is going to point to the first one, Alan. And item is going to point to the birthday that's associated with Alan. So that'll be the value, right? And then, so there will be X.key and X.item. And also, you can say another one here. I didn't draw it. I'll draw it quickly. Also, you have, can I possibly make this a little bit, maybe I'll put it here. Okay. And then this guy here, I'll make it a little bit downwards. Okay. So now you can see this one here. There's another one called fourth, which means to move the cursor. So what does it really mean? When I say over here, let's say X dot fourth. If I say this, so that means I'm going to move the name over here rather than here. It's now going to point to not Alan, the next one next to Alan. Now it's going to point to Mark. And then when I say what about X.item? X.item would just be X.key would be Mark, and also X.item would be just the next one that's in the table, right? It's gonna move one row at a time. So the green one over here is pointing to this row, and the purple one is pointing to this row, depending on whether it's a key or item. Okay, you kind of see what I mean here. So by using the hash table iteration cursor, specifically using the key and also item in the fourth, with this kind of combination, we can easily create tuple for the need of this particular my hash table iteration cursor. That's basically what we want to do. So when I say item over here, right, pointing to this particular objects, what I really want is, because internally, remember, we actually got, if I go back to my hash table iteration cursor, I just need to declare one more thing. Okay, that's something the missing piece of the puzzle. I would say IC is going to be a hash table iteration cursor, and this is the internal implementation for my iteration cursor. Hash table iteration cursor, and then I will need to give some generic parameter. In that case, it will be just a G followed by H. Okay, you can look up the declaration for hash table iteration cursor. If I say that, now I can simply say IC is simply assigned to the whatever the implementation is dot new cursor. That's what I will get, right? So now, to complete the picture, you can think about this. I have one more implementation for my hash table iteration cursor. So that will be IC. You can think about IC is really pointing to this particular iteration cursor. You can think about IC is like the X over here. So now, whenever I say IC the key and IC the item, it's not going to point to some element, some key and value depending on where the cursor is. If I say IC the fourth, it's also going to move maybe from the green over here to the purple over here, right? To the next row, basically. Okay. Try to visualize what's happening over here in order for you to understand what I'm trying to do here. Okay, let me go back to finish the coding. So now here for the do, I will simply say the result is simply assigned to just a tuple. So now I can say IC dot item and also IC dot key. Okay, let's try to compile that quickly. Okay. Did I spell it wrong? Hash table iteration cursor. Hash table iteration. Oh, sorry, it's typo. Okay, that'll be fine. Okay, I definitely meant to refer to that particular base class. So now everything compiles. So now we are done with the supplier side. Okay, I'm gonna write just a small test cases in the client side to really complete the picture. But now for the supplier side, we are done. Okay, let me summarize very quickly, and then we'll go to the client test. All we have done was as follows. We started with the birthday book. In order to make it iterable, we have to choose by what each item the client will retrieve should be like. So that should be a tuple of birthday and name. In order to do it, we first try to really use imp.newCursor. That's what we try. And then, as we explained previously, it's not going to work. So you really want to review this part of the recording carefully. And then we try to simply create another class on our own, which is called my hash table iteration cursor. Okay, if I go to that particular class over there, my hash table iteration cursor, that class over there has two internal implementation attributes. One is the hash table, the other one is the hash table iteration cursor. So this is the base class that returns G only. However, by using IC.key, so this IC.key is not the standard iteration cursor feature. However, because the hash table iteration cursor is a descendant class of iteration cursor, it can definitely add new feature to it. That's how do I know? I read the API, so that you should do the same. So now if you go back to the picture over here, so now what we're trying to do is like this. The hash table, which is an implementation, if you say the hash table dot new cursor is going to give you hash table iteration cursor, and it has support the key and also the item. Every time if you do it, it's just going to point to maybe the first row for the key and also the first row for the item. As soon as you say fourth, it's not going to say, it's going to point to the second row for the key, and also going to point to the second row for the value. Okay, so you gotta move like that. In order for me to really exploit this particular iteration cursor from the base library, I just added another implementation attribute IC of type #table iteration cursor. Okay, really want to get this particular diagram straight in your mind. Finally, I would like to write a small test just to complete the picture. Okay, if I go to the tests over here, let's go back to T2. Okay, let's finish T2 in the client side. So now, if I try to compile, let's see what's going to happen. Well, it says that iteration expression should conform to iterable. Okay, let's expand the error messages over here. It's saying that we are expecting, since you are going across BB directly, so BB should be of some type that's iterable. Okay, but we did say birthday book over here inherits from iterable, right? That's what we said previously. So now it seems to be fine. However, try to get a little bit hints from the compiler just in case you get lost. I know it's difficult, but give it a try. It says that we're expecting iterable. It gave me something that's detachable birthday book. Detachable simply means you're giving an object that could be void. Okay, so now what could be potentially the issue over here? Okay, hopefully you have spotted the error because we're using BB as a local variable, but we never initialize it. That's why. Okay, so what I will do is I'll say create BB dot make an empty book. That's the reason. Okay, be careful. Okay, if I say compile, everything's working. So now what I would like to do is this. Let me, before I use the cross, let me just make sure I have a complete test for you to try. Let me just try to insert something into the birthday book. Okay, I can reuse something from before. I can say maybe I will simply get different birthday, right? How about I simply reuse them? Okay, so I'll put the name in just a little bit later. Okay, so now let me just redo this particular birthday book. So I need to put the name. So I got Jack, I got Jill, I got Max. So they should be name. And also I got February 17th, for example, and also others, right? That should be a day, birthday. Okay, let's make sure everything will just compile. That's good. Okay, so now after that, so now rather than simply use what I did previously by using the model, right? That's something you should get used to as well. But now how can I use it, test the iterable? One way to do it is to say I'm going to create another local variable. Okay, let me say linked list. I know that every time when I get something back from the iterable birthday book, I get a tuple back. Why don't I just collect all the tuples first in a linked list, and then I can query about this particular linked list. Let me show you what I mean. So I can say maybe just maybe tuples. Linked list of basically it's going to be a tuple of birthday, right? Because it can be iterable, so it should be birthday and also name. Let me just copy this. And then I'm going to put birthday and name over here. So now, before I do it, I need to create over here. And then tuples dot make. Okay, let me just make sure everything compile. Oh, I got some syntax error. Let's see. Okay, sorry. It should be a tuple. Okay. Just be careful with the syntax. Oops, accidentally I closed my tests. Okay, let's go back here. And let's say compile. Everything compiles. So now what I need to do is inside this particular loop, now I can already across the BB, and every X is simply just a tuple. So now I can say tuples dot extend to the end X. Okay, everything should also compile. You should really try to compile your projects every logical units. I would say since I just did one line, so I should really compile that. Now, how can we do a test? I can say result is the same as, now tuples should really get all the entries collected by iterating through the BB, right? So now I should say, first of all, the count should be equal to 3. I got 3, I got basically Jack, Jill. I only got these 2. Oh, only 2 records. Okay, so let me say 2. Okay, first of all, and then I can try to run the tests. Did I actually open the browser? Let's take a look. Oh, there's something I forgot to mention to finish off. Okay, at the moment, our iteration cursor will simply not terminate, which is very bad. Okay, I simply forgot. If you go to hash table, my hash table iteration cursor. Okay, if you go there, we actually haven't implemented after and forth, so that's why you never actually move your cursor to the right by one position. Okay, but basically what we're gonna do is we're simply gonna use whatever I see over here to tell us whether we are reaching the end of the hash table. I just forgot. Okay, I would say result is assigned to, first of all, IC.after, as easy as that. We're just using that internal cursor. And then we'll say IC.fourth. Okay, so that part is really crucial. Otherwise, you run into infinite loop. If your iPhone Studio is not making noise, you may want to shut it down and then open it again, launch it again because of the infinite loop. Okay, let me go back here. And then if I try to compile and run it again, let's see what happened. Now everything just worked. Okay, let me do one more test for you. So the additional assertion I would like to add is by adding a conjunction. So let's say we say and. So now we know that there are two tuples over there. So let's talk about the first tuple, for example. I'll leave the second tuple as an exercise for you. So let's say go to the first tuples. I can use the indexing notation to say the first tuple. And then dot, I want to go to the first item because I know the first item should be a birthday over here, and the second item should be a name. Let's now try to do this. So now go to item 1, and then should be the same as, let me create anonymous object over here to compare. Presumably, tilde is going to call the is equal feature in the birthday class. Birthday over here dot make. So now it should be a month and followed by a day. So now let's say the first record should be for Jack. And Jack basically will be January 14th. So I'll say 01, and then I would say 14. Don't be confused about the different order over here. They're just different features are being called. Okay, but if we call the constructor explicitly, it should be the month followed by day. And also, still the first tuple over here, I can say the item, go to the second item, which should be the name. Right? Should be the name. In this case, it should be Jack. So now I would say again, I create another anonymous object to say creates, and then I can say here name dot make. So that should be Jack. So now if I say compile, everything compile. Let's see if that runs. Okay, everything works. I want to show you just one more thing. You can see referring to elements in the tuple by position, either position 1 or position 2 is fine. It can always work, but it will be convenient if we can refer to fields of the tuple by their name rather than position. I'll show you just one more thing. Okay. So now if I say for this particular tuple, I'm going to retrieve from the linked list, let me name them. I can say BD is going to be the name for the first tuple, and then N is going to be the name for the second elements. But if you do this particular syntax by adding names of the fields in a tuple, you have to put semicolon if you want to do the syntax. Okay. So now what I will do is I'm going to copy these two. So these two still works. Okay. The accessing the fields in a tuple by position always works, but you can also add the names of the fields. So now rather than saying the item 1, so now I can say it should be BD. And now accessing item 2 should now be N. Everything should just still compile, and now if I run it, it still works. Okay, so this will complete this particular example of making our birthday book class iterable. It's quite a long explanation over here, but I think to me, from my point of view, the most important part you want to understand is about why we started with this particular implementation over here by just using the new cursor from hash table. Simply just wouldn't work. Understand that thoroughly first, and then we move on to this particular implementation by creating the my hash table iteration cursor, the hard case. It works programmatically, but you also need to understand at the runtime how this particular internal iteration cursor for the my iteration cursor class actually how it works. The way it works is by using the new cursor from the hash table over here. Okay, so these are the main points you really want to review, not just for this coming lab test, but also for your knowledge about design patterns.